Das Webinar hat auch schon angefangen. Vielleicht machen wir kurz einen Check. Let's do a quick check if the technology works. Maybe our participants can help you with that. Can you enter me a short okay or yes or go in the chat on the right side of the screen to ensure that you can see us and that you can hear me? Yeah, someone's writing, another one. Yes, thank you very much for your support. Okay, now back to the slides. If everything seems to be fine, yeah. Okay. Please make your introduction before you hand over to my side.
Okay. Well, welcome everybody to this first webinar on. I will continue in Flemish, if you agree, Reinhard. Welkom iedereen op deze eerste webinar rond thermische opslag. Dit biedt oplossingen zowel nu als na 2020, eens de consumententariefregeling wegvalt. Deze webinar gaat door in het Engels door Reinhard van MyPV. Indien er vragen zijn, kunnen jullie onderaan de vraag intypen. Als ik kan, beantwoord ik die tijdens de presentatie. Indien niet, kan die achteraf ook verder behandeld worden. Het timeframe is in principe tot 5 uur maximaal. And then I will give the floor to Reinhard to start the presentation.
Yeah, thank you very much, Yves, and also thank you for the chance for us to present our portfolio here today together with GPC Europe. My name is Reinhard Hofstetter. I'm responsible for international sales at MyPV, and today I want to give you a short and simple overview of our solutions. And hot water and space heating from photovoltaics is our topic. So I would like to start with a brief introduction. The guys that are shown on this slide are the entrepreneurs of MyPV. There is Dr. Gerhard Rimpler and Markus Grundendorfer, who's our sales manager. And these guys together, they have more than a few decades of experience on solar electronics design. They founded the inverter division in an Austrian company a few decades ago. And Dr. Rimpler, as myself also, he has also very much experience in solar thermal systems. So systems that were built with collectors, with pipes, with pumps to get sun's heat into our boilers. But nowadays we do it with photovoltaics instead of solar thermal systems, and in doing so we make it many times easier and we make it also cheaper. And this is what I want to show you today. MyPV was founded in 2011. Basically it was a trading company, a distributor. But during the years, it changed its business model. We became a pure manufacturer. We invented our first own product in 2014, which is a pure off-grid product. It's a DC solution where the panels are directly connected to the heater. And over the years, we also invented AC solutions to use excessive PV energy in on-grid PV systems. Why is there the idea to create heat out of PV power? So the answer is on this diagram. A few years ago, let's say 8 years in the past, PV power was far too expensive to create heat with. It was very valuable. It was unthinkable that you use it on a resistor for heating. But things have changed. It has become the cheapest form of energy production ever since. And with this development, we have the foundation, the basic for our innovations. And yeah, today it's not too expensive anymore to use power from PV panel. It's many times easier and it's also cheaper. Most of the people are familiar with their demand of electricity in their single family homes. So most of them know that they use, for example, 4,000 kilowatt hours of power in their building. But hardly anyone knows that they need approximately the same amount of energy for hot water heating. And photovoltaics can easily cover also this segment to a very huge amount. And then there's a new topic at MyPV for very new buildings, for buildings that are built according to modern building standards. There is also the fact that the demand for space heating is very low. And for these buildings, we can also think about using hot heat from photovoltaics to cover the space heating energy demand. But we do not recommend to use this in old buildings. We recommend to use this only in new buildings. But what we can always do is hot water heating with excessive PV power or with direct PV power. So now, Eva, it's up to you to give you a short overview over this slide.
Deze slide toont eigenlijk de drie verschillende opties die aangeboden worden met MyPV. En de eerste, ik probeer die pointer te nemen.
The pointer is the icon with the arrow.
I know, it doesn't seem to work well.
Okay, so I use my one.
Yeah. So if you go to ELWA, the first option, dat is er een waarbij dat PV direct wordt aangesloten op een elektrische weerstand. Waarbij dat je 2 kilowatt aan vermogen kunt loslaten op die weerstand van je PV. En waarbij dat er 1 kilowatt kan aangestuurd worden met die elektrische stekker dat je daar ziet. Zeer simpel in te stellen. Je stelt die in, bij PV mag hij een maximale temperatuur hebben van bijvoorbeeld 80 graden. Maar hij moet altijd een minimumtemperatuur geven van bijvoorbeeld 50 graden of 45 graden met de AC-stekker. Dat is echt een off-grid situatie dat je kunt inbeelden bij bijvoorbeeld een zwembad achteraan, dat je niet eerst dat vermogen moet omzetten in AC en dan maar kabels tot daar lopen en dergelijke meer. Omgekeerd, als er reeds 10 kilowatt aan omvormend vermogen geïnstalleerd is en je wil nog extra bijplaatsen, is dat een optie. Dat is de eerste en meest simpele optie. Als je dan rechts kijkt, if you look to the right, for both options, one is with a electronic controller, the most right one, and the left one of those two, that's in the middle. The electronics are built in within the resistance. Wat dat je in deze optie doet, in beide opties, is dat je meet wat er op het net gaat. Dus alle injectie wordt gemeten op die power meter. En stel dat je 2 kilowatt injecteert, dan zal die ook die 2 kilowatt naar die weerstand duwen. Stel dat je 1 kilowatt injecteert, stuurt hij 1 kilowatt naar die weerstand. Stel dat je niet injecteert, dat je afneemt van het net, dan zal hij ook geen warmte produceren op dat moment. Die middenste, die LWE, is zeer simpel in te stellen door een UTP-kabel te verbinden met die weerstand. Heb je reeds een bestaande installatie en een bestaande weerstand, dan gaat je eerder naar die AC-TOR, waarbij dat je ook alle overtollige energie, dus alle injectie, stuurt naar die sturing, zeg maar. En vanuit die sturing kun je modulair die weerstand gaan inregelen tussen 0 en 3 kilowatt. Dus opnieuw hetzelfde verhaal. Stel dat je 1000 watt injecteert, gaat die 1000 watt naar die weerstand duwen. Stel dat je 2 kilowatt injecteert, stuurt hem 2 kilowatt. Stel dat je niet injecteert, maar dat je afneemt van het net, dan stopt hij ook om energie naar die weerstand te duwen. Extra op die AC-tor is dat je ook een relais hebt, waarbij dat je eens dat je boven de 3 kilowatt injecteert, dat hij ook iets anders kan aansturen. Maar belangrijk, dat ik wou meegeven hier, dat is dat er 3 producten zijn. 1, die grijze is off-grid. 2, die groene wordt gestuurd vanuit de powermeter. En 3, daarbij hoef je geen extra weerstand aan te kopen. Dat kan op de bestaande installatie en daarvoor heb je een aparte sturing. Reinhard?
Yeah. Okay, thank you very much. So I can repeat again in English now. So the most simple way to use PV power for heating is the ELWA. ELWA means electronic water heater. So it is an immersion heater which is directly connected to PV panels. There is no PV inverter in between. 4 to 8 panels are usable, and the input voltage that you have to consider is between 100 and 360 volts. So this can be a thin film panel, it can be a polycrystalline panel, monocrystalline, does not matter. Just the input voltage has to be within our specifications. I try to bring me on the bigger screen. Maybe you can deactivate your camera, Eva, or okay, does not matter now. Yeah, perfect. So what I have here is a model of the ELWA, and everything on this model is as it is on the original product, with one exception. The immersion heater is actually longer. It is 47 centimeters long on the real product. And to assemble the ELWA in a hot water boiler or in a storage tank, there is a 1.5 inch connection thread here. So this is a standard size for most of the boilers and the tanks that are out there. And the heating elements are within the hot water tank or in the buffer tank. So what is outside of the tank is this box. And there is the know-how from MyPV integrated, because what makes this immersion heater PV ready is its ability to linear power control. It can adjust its power output to the power that comes from the PV very fast. And your direct connection is made via multi-contact plugs on the bottom. Okay, there's a black background. Probably you see it better now. So you have a direct connection to the panels, 100 to 360 volts DC voltage. The target temperature can be adjusted with a rotation knob, and there are some LED signals which inform you about the current status of the heater. What else? There is also a data logger integrated. You can use an infrared connector from MyPV to download the data logger. And meanwhile, you have already recognized that there is also a mains plug. This is just an option for backup. It's not necessary to use it. We have customers who have never ever used this power cord here, because the device is running on DC alone. It also works during a blackout. When you plug it into a socket, the ELWA automatically checks if the minimum temperature is already reached in the afternoon by the sun. If so, it does not do anything, but if not, because maybe it was a cloudy day or a winter day, it starts with AC backup. So this is an option. It's not necessary to use it. The device even works during a blackout because it works on DC power alone. Now I try to go back to the slides. And here we have some technical data again. The DC side can adjust its power output from 0 to 2000 watts. The internal consumption is just 2 watts, so it's very efficient. And the optional AC backup is available with 750 watts AC. And these 2 power outputs can work simultaneous. So it is not the case that the DC side shuts off when AC starts. Definitely not. So even if the sun is already below the horizon or nearly below the horizon, the DC side can be used even when at the same time the AC side already started to work. In doing so, we have the ability to increase the solar coverage ratio to a maximum. This is a very, very cool feature of the product. What is special, you can use two elvas, for example, in a huge storage tank. You can connect two units parallel to one and the same panel string. And if you do so, you adjust the elva on the top as the master and the elva on the bottom as the slave. And the master has priority. What is the benefit? You have target temperature due to this small volume on the top side quite faster. And if it is on target temperature, the rest of the energy from your PV system goes to the heater on the bottom, and the volume down there can be heated up as well with PV power, while you always have your temperature of the hot water ensured on the top. Okay, this was the DC solution. This was the first product from MyPV. It's on the market since 2014. And during 2014, it was definitely ahead of its time. So it took some years to get into the minds of the people. Everyone worked with solar thermal systems. Even I did those days. But nowadays, it's so easy, it cannot be easier. My 5-year-old daughter can connect this solar cycle to the unit, and then it's done. I do not know how it is in Belgium, but in Austria, you do not even need a permission from the grid operator to use ELVA, because there is simply no connection to the grid. So also the bureaucratic effort is quite low. You screw it in, you connect it, and that's it. No pumps, no valves, no maintenance. The only thing you have to consider is calcium in the water. When you use the heating rod in drinking water, it depends on the calcium amount in the water. We recommend not to go above 60 degrees centigrade with the target temperature in drinking water. But if you are in a storage tank, in space heating water, it does not matter. Go up with the target temperature and use your storage capacities as far as possible. Okay, DC ELVA. That's the only DC product that we have. All our other products are AC products. And the question is, how do you measure how much excessive energy is available? How much energy would be sent to the grid? And therefore, I would like to present our own solution. It's the MyPV Power Meter. It's installed in the feed-in point next to the meter of your energy supplier. And it has three small sensors. These are clamp-on transducers. You clamp it over the face of your feed-in point. All three phases are measured. And if there is excess power, if there is the production power bigger than the power of that is used by the devices in your house, then the power meter detects exactly this amount and it sends the information to the AC ELVA E or to the actor. The communication happens via Ethernet. The standard way to use it is that all devices are connected to your internet router. So power meter is connected to the router, actor is connected, or AC ELVA E is connected to the router. And these devices, they find themselves automatically in the network. There is also the possibility to connect them directly if you do not have a network in your building. If you do not have internet access, it does not matter. You can use a direct connection, but this has to be a special Ethernet cable. It has to be a so-called crossover cable. This is what you have to consider. But this is also standard. You connect them together directly and that's it. In some cases, it's not possible to assemble an Ethernet connection, to assemble an Ethernet wire. And in these situations, our customers often decide to use power line adapters. I think in German, they are called D-Link. You have this adapter for your main socket on two spots in your building, and via the AC line, they communicate with each other. So you can do this, it's done in many times in that way, but actually it does not improve the signal quality. We have to be serious here, but it's definitely a way to do some installations where you cannot install a wire. Okay, but one of our philosophies is that we are open for the signal sources of other brands, of other manufacturers. It's not necessary to use the MyPV power meter in every situation. Just an example, we have inverter manufacturers who can already provide the excess power signal. There are also a few battery manufacturers out there. And of course, there's a huge number of smart home systems who are already able to control our devices. And then you do not need the MyPV power meter. If you plan your project, please just give us a short email, send us a short email, and we will check in your situation if your configuration works together or not, because the state of the implementation is not always equal between ACLYE, Actor, and Actor 9S. Some of the brands are a little slower than others, and we can give you the latest info if you want to plan your project. Okay, and here we are, ACLYE. It looks exactly or nearly the same as the ELVA. It has the same body, the same length of immersion heaters, so 47 centimeters, and also a 1.5-inch connection thread. But it does not have the multi-contact plugs on the bottom. There is no DC connection. ACLYE is used in a building with an on-grid PV system. So there are the PV panels, yes, but there is a PV inverter in between. And this PV inverter supplies your electric appliances with priority. So your TV, your dishwasher, whatever. And the energy that would be sent into the power grid is what is detected by the MyPV power meter or by one of our compatible partners. And this is the energy that we want to use. And therefore, ACLYE always takes the energy out of a socket. You have, or we recommend to use a separate fuse for this socket. The power output of the device can be up to 3 kilowatts. And if you use the MyPV power meter to detect the excess energy amount, the control of this heat output with ACLYE happens very fast and very accurate. If you just switch on the light in this living room here, you have lower excessive energy available and the heater immediately reduces its power output. It ensures that the balance in the feed-in point is always made very accurate. It avoids import from the grid and feed-in into the power grid. So it adjusts its power output linearly from 0 to 3000 watts. Very fast and very accurate. Okay, technical data. This is a 3 kilowatt unit, and the power always comes via a power cord. There's always a mains plug, and the cord is 2.8 meters long. What is important to say that our type of power control is compliant with the rules of the grid operators, especially in Austria and Germany, in Switzerland, because we have a pure sinusoidal output for the power control. We do not have so-called thyristor controllers. We do not have so-called phase angle control, which cuts the sine wave as your dimmer does with the light in our rooms. It has a pure sinusoidal output, and this is really a quality property. Yeah, and the E from ACLYE is for Ethernet, so it's always connected via Ethernet cable to the router or with the crossover Ethernet cable to the power meter directly. As for the ELVA, also the ACLYE has the option for backup power. This is deactivated with our factory preset, but you can go on a web interface of the heater, because as soon as it is connected to a router, it has a web interface. You can enter the IP address in your web browser and you do the adjustments on the web interface. And yeah, there you can adjust a minimum temperature, which has to be ensured all the time or during 2 time frames, for example, 2 hours in the morning, 3 hours in the evening, where you ensure a minimum temperature to ensure your comfort for all the days where there's not enough excessive power from the sun available. But this is an option. In Europe, we recommend to use this option during summertime, because during wintertime, you usually have your conventional heating system, which does this backup of the hot water boiler anyway, your gas boiler, your heat pump, whatever. So it's an option, and you can activate it very easily on the web interface. So what is more and more important when we are talking about the transition of our energy economy to renewable energies is the topic of storage. Yeah, it's all about storage capacities, and we are all talking about battery systems in our home. And therefore, we have this bar chart here. When you install a battery system in your building, there is usually a capacity, let's say, from 5 kilowatt hours to 10 kilowatt hours. This is a quite low capacity, but it comes with a huge investment step. Alternatively, you can use your excessive power, and instead of charging up a battery, you can use a MyPV solution to heat up your hot water boiler. The investment is many times lower, and the capacities in your hot water boiler are times higher. And for very new buildings, but I will not go too much into detail on this topic, we also have the ability to use the excessive energy for space heating. And in this example here, the floor of a 100 square meter single family home is heated up for 4 degrees centigrade. And this means 25 kilowatt hours of storage capacity. MyPV can be a cheap alternative to battery systems, but we do not compete with batteries. This is very important to say. We have a number of very good cooperations with battery brands named Warmte, named E3DC, named RCT, or with battery systems that work together and are controlled via the SMA Sunny Home Manager. It works as well. And this chart here, it is unfortunately in German. I'm sorry for that, but it gives a very good explanation about the possibilities we have. Let's take a look on a single family home. It is installed, let's say, with a 5 kilowatt peak on-grid system. The average self-consumption rate that is possible is approximately 1/3 of the energy. The rest of the energy is sent to the grid. So what is very popular, especially in Germany, but also here in Austria, is we install a battery system, okay? You take this huge investment and you increase your self-consumption ratio by the time of 2. So approximately 2/3 of your produced PV power is now used in your building. Alternatively, you can use a MyPV solution and heat up your hot water with excessive power. And then the self-consumption ratio is about 80%. So even higher at lower investment. But again, MyPV does not compete with battery systems. You can use both together. Use an SMA Sunny Home Manager with a BYD battery, whatever, I do not care. And you can increase your self-consumption ratio higher to a maximum of more than 90%. What is important? If there is a battery, we recommend that our solutions are used at the lowest priority, which means if there is a battery, you should charge up the battery. You should load the battery first. You should load the battery with priority. Why is that? It's easy. As soon as it is heat in the hot water boiler, we cannot get back electricity out of it. So then the energy is heat, and that's it. You do not get power out of it again. So use a battery storage first if it is installed. But for most of the battery systems, we see the situation that on a sunny spring day or a sunny day in autumn, most of the battery systems are fully charged, are fully loaded in the late morning. And from this point forward, we have a huge amount of excessive energy available, which we can again use for power to heat in our hot water boiler. That's our idea. We avoid feed-in. We avoid the shutdown of the PV systems. This is, let's think 10 years into the future. Every building, hopefully every building will have a PV system on the roof. And what if all batteries are fully charged? Our grid operator maybe does not have another option as shutting down the PV systems. because the transmission capacities of our power grids are limited. And this can be understood from a technical point of view, but from an ecological point of view, it's a disaster. We would have an amazing resource available. We would have renewable energy available for free, and we cannot use it because the PV inverters shut down. And this is a disaster, and we do not want this. And that's why we say, let's do power to heat in the last way, and use every kilowatt hour that we can get out of our renewables. So this is the idea. Yeah, there is also a way to do this calculation on the PV self-consumption ratio and on the hot water coverage ratio. Therefore, we have this paper disk. This is, let's say, it's a simple tool for your pocket. When you are talking to your customers, they want to have an idea what is possible, what does it mean for their feed-in, what does it mean for their hot water production. And this tool is very easy. You adjust with the arrow here the installed PV power, and you can get out the data of the numbers here. So this is a useful tool when you do consulting, when you do sales, and your customers get an idea of the possibilities. And this is for free. We can give you as much of this paper disk as you like. Yeah, you will order them by GPC, and we will provide them to GPC if you like. I can really recommend this tool here. Okay, and now there is the Actor. When the Actor came on the market in 2017, it was first misunderstood by many people. Why is that? The people saw the display and they thought, okay, well, this is just one more smart home system. Okay, I know this stuff. But they were wrong. Technically speaking, the Actor is an AC power controller. What can you do with this AC power controller? You can make a standard resistor, a standard electric heater, an ohmic heating element, PV ready. Because now you can adjust the power of this heating element according to your available excessive PV power. And this is the smart thing here. I always compare Actor with the gearbox in your car. You have the PV panels on the roof. Okay, this is a combustion engine. We have the immersion heater in our boiler, which are the wheels where we can get the service from that we want. But it needs something smart in between. And this is the Actor. This is the gearbox which makes the immersion heater PV ready. Yeah, it's very small. On the bottom, you can connect in a main socket a single phase immersion heater or a heating mat or an infrared panel. I do not care, but it has to be a pure ohmic load in every case. So everything of these connections here is pluggable. You do not need to assemble terminal blocks. You do not need to assemble PG connections. You do not have to open a case to install it. It's everything is plug and play. There's also the Ethernet port for the communication with the signal source, and one temperature sensor is all with the Actor in the box, and also this sensor is pre-wired and it can be connected. It can be plugged into the Actor. And this plug on the right side is for a relay. It also has a relay where you can switch another 3 kilowatt load, for example. It can be used for different things depending on the operation mode. For example, you can release a heat pump if you have enough energy available to drive the heat pump. And for the installation, we recommend to use a cover on the bottom. So I do not know the English word. I would say it's a channel, a cable channel, as we say in German, cable channel. And it covers all the wires. It covers the cables, and then it looks smart. It looks beautiful. It's professional. It's a professional installation when you cover all those things on the bottom, I would say. Yeah, the other thing is with the display, we have a very intuitive control. I always say when you just set the time to wake up in the next morning with your smartphone, you are also able to do the adjustments on the actor. So it's very intuitive. All the connections are pluggable. It's very small. This is smaller than a sheet of paper. And so this was unique sales point number 3. What else? We have an open communication interface. If you do not want to use the MyPV power meter, if you do not want to use one of the other brands who can talk to our devices, if you want to program the control of the actor your own, I give you the communication protocol of this Ethernet port. This is not a secret. This is our philosophy. We have an open communication interface. So many advantages to make a standard a standard immersion heater PV ready. All the technical data are again on this sheet here. And then there is the Actor 9S. It is the same unit when you look at it from the front view, but it is different on the bottom. You also see a device here. This is not a model. This is a product out from the factory. And this is really small. So it's approximately 1 kilogram heavy. And instead of a main socket, we have a 3-phase output. It's the Actor 9S. And with three phases, its power output is 9 kilowatt maximum. So you have a power stage of 9 kilowatt in this small unit. And there is no other competitor product who is able to offer such compact solution. Also, in this case, every connector is pluggable. So they're same philosophy in that situation. But with a 3-phase product, we have a number of more possibilities. So the standard way to use it would be a 9 kilowatt heater with 3 phases. Yeah, but this is available also from other manufacturers. But what is again special from the MyPV solution is our ability that we can switch the control phase from output 1 to output 2 to output 3. So what does it mean for your projects? Let's assume you have a very huge storage tank. Yeah, you want to do a stratification charge to get hot water on the top quite fast. And this is smarter than using a powerful immersion heater just in the bottom. So assume you have excessive power of 1 kilowatt or 2 kilowatt. We will do the linear power control according to your excessive energy amount with the heater on the top. And now let's assume sun rises up. Your excessive energy is now 4 kilowatts. Then we will switch the heater on the top static with a relay 3 kilowatts. And we do the linear power control at the heater in the middle. And this is what just MyPV can do. And now you know what's happening when we have 7 kilowatt excess power. We switch heater on the top and heater in the middle static with a relay 3 kilowatts each. And we do the linear power control with the heater on the bottom. And this is the cool thing. And also for new buildings, which are built according to modern standards for low energy houses, we can use output 2 and output 3, for example, for electric space heating. Yeah? And therefore, we have a pure solar electric building. We do not have any pipes anymore, no boilers, no biomass boilers, no heat pumps, no gas boilers, whatever. We heat up this building to a huge amount with power from your own roof. And there's an example. I will show it to you a little later. So all the details are summed up here. I will not go to all the lines. What is important, all 3 outputs are controllable. I already have explained this. And as for the ACLYE, the power control happens with a pure sine wave output. No thyristor, no phase angle control, which cuts the sine wave. This is absolutely along with all the rules of the grid operators. Okay, what is important to know when it's a retrofitting application? Let's assume you have a 3 kilowatt heater, a 3-phase heater that should remain in the tank. Yeah, you want to use it also in the future. That's not a problem. What do you have to consider? Basically, there's just one thing that is important. This heater has to be equipped with a neutral conductor. For example, in Switzerland, we often have the situation that there are heaters out there with 3 times 400 volts, and there is no way to connect a neutral conductor. And then we have to say, sorry, this is important. We cannot use the Actro 9S here. But for all the heaters who work not with 3 times 400 volts, but with 3 times 230 volts, so they have a neutral conductor, the Actro can be used for retrofitting as well. Okay, very important. Neutral conductor is required. The display, I have already mentioned that it leads to a very intuitive usage of the Actro and its settings. And if someone of you is already familiar to the single-phase Actro, you will not have any problem to start working with the 3-phase Actro. So it's a color touch display. It's you cannot wipe it, but you can touch it. So it's not absolutely like your smartphone, but it's absolutely comfortable for the operation. Okay, operation modes, very important. The single-phase Actro comes from factory with 8 different operation modes. And there is no need to buy any license or to get any keywords from MyPV. All of these operation modes are available as soon as you pick the device out of the box. And now for the rest of the webinar, I will give you an overview of these applications here. So there is not only the way, I'm sorry, there is not only the way to use it for hot water. You can also do a few other things with this unit. So standard way is for the Actro 9S, 3-phase 9 kilowatt immersion heater. You want to use all your excessive energy on a 9 kilowatt resistor, you can do this. And the excessive energy can be detected by the power meter or by one of our compatible partners. This is the standard way. Accessory parts, important when it's not a retrofitting solution, and many people want to get all parts from the same supplier. Then you have the chance to get these accessory parts also from MyPV. We have a single-phase 3 kilowatt heater for the Actro, and we have a 3-phase 9 kilowatt heater for the Actro 9S. And this is available there. You can be sure that all components fit together. And this is something that is always available if you like. And also for the Actro 9S, the 3-phase 9 kilowatt load, it is possible to use 3 single-phase 3 kilowatt heaters. I have to be very careful with my explanation with all these numbers. 3 single-phase 3 kilowatt heaters with the Actro 9S. Then you are allowed to cut off the mains plug and connect them to 3 outputs. So you can do this stratification charge. You can also use mode 2 for stratification charge. In mode 2, the Actro can change its power output between 2 heaters. It also works with the single-phase Actro via the relay. You can use a 3 kilowatt heater on the top and a 3 kilowatt heater on the bottom, and one after the other is supplied with the excessive PV power. But with the Actro 9S, you can do the same. But to switch over from one 3-phase load to another 3-phase load, we cannot do this directly with the integrated relay. Therefore, we need 2 additional external relays. In English, they are called normally closed and normally open, I think. In Germany, we say they are Schütz. So an external switch, which is activated by our relay, and this switch switches over the 3-phase load. You can also do this with the Actro 9S. Hot water and heat pump. This is very important. From our point of view, a heat pump is not really PV ready. it cannot scale its electricity power demand up and down. You always need a certain level of electric power to drive the compressor in the heat pump. Let's say for a domestic hot water heat pump, we are talking about 400 watts, for example. For a space heating heat pump in the building, maybe we are talking about, maybe, do not know, 5 kilowatts or whatever. And the thing is that a heat pump cannot reduce its electricity demand to 0 watts. It's a complex mechanic hydraulic system. It needs a certain level to drive the electric motor of the compressor. And therefore, we see that that electric immersion heaters are fit quite better to PV systems, because we can scale the power output up and down. We can switch it on and off every second. It does not matter. You cannot do this with a heat pump. But if you want to combine both components, we can release a heat pump. And we can release it from the moment forward where you have enough energy available to drive the heat pump. And then you can adjust 2 time frames, a minimum time frame where the heat pump has to work definitely. And then you can adjust the second time frame where the heat pump has to be shut off. This is then according to the recommendations of the heat pump manufacturer. And the reason is that you cannot switch on and off a heat pump every second. This would destroy it, and you have to be able, you take care of it. And therefore we have these 2 time frames. Okay, and while the heat pump is released and it works with PV power, we can at the same time we can do the power adjustment of the immersion heater. If there are production peaks because the clouds move along the sky, we can react on that peaks and use the power on the immersion heater at the same time while the heat pump is running. So at the end of the day, you will reduce the working time of your heat pump. You will expand the lifespan of your heat pump, and this is the benefit when you combine both components. Okay, and now there's the topic of the low energy buildings. When we build our single family homes today, they need such a little amount of energy for electric space heating that from our point of view, a conventional space heating system that works with pipes is overdimensioned. It's an overkill in terms of material, it's an overkill in terms of installation effort, in terms of power, in terms of installation costs. We say that for a low energy building, it's not necessary to install a space heating system with pipes. We can install a bigger PV system instead. And now I'm talking about powers of 10 kilowatt peaks or bigger. And we supply the electric appliances in the building. We supply the immersion heater in your hot water boiler, and we supply the electric mat in your electric underfloor heating system. In this concept, there is also the idea of using infrared panels, but we say it's just for temporary use. For example, when I'm in the bathroom 10 minutes in the morning and I brush my teeth and then I go to work, it's enough to switch an infrared panel on for this time, and it does not need to be linear power controlled for 10 minutes. This would not make sense. We recommend to do the power control during the day in our underfloor heating mat, in the electric heating mat, and to use it as an energy storage for our day peaks. And we do the same with the hot water boiler. And this is as the actual display looks like in this operation mode. You can, of course, adjust different temperature targets for excessive power and for a minimum temperature. Therefore, so the benefit is you reduce the input from the power grid for backup as much as possible. For example, I would say I heat up my electric hot water boiler to 60 degrees centigrade, and I heat up my rooms to 22, 23 degrees centigrade when I have excessive PV power. When on short days during winter time, when there's not as much excessive power available, I heat up my boiler just on 45 degrees or 50 degrees, and I ensure a minimum temperature in my rooms of 20 or 21 degrees. And in doing so, I reduce the amount of energy that comes from the grid as much as possible. And I have completely removed my conventional heating system in the building. And in doing so, we also save space. There is no need for a boiler room in our basement. Yeah, we have just the hot water boiler, and the rest of the components is quite small. I will show you an example of a project that we have done. The principle is basically the same as it is with a heat pump then. So a heat pump, it evaporates a cooling liquid to get energy from the ambient air. And to drive the heat pump, you need power from the grid. The heat pump has a disadvantage. It can only produce heat. It cannot produce electricity for your electric appliances. This amount of energy has to be imported from the grid in every time, together with the energy that is required to drive the heat pump. What we do not do, and we use direct electric heating systems, but what we not do is the principle in the middle. What we do is the principle on the bottom. We use the energy from our own building, from our PV system. The physical form of the energy is now electricity. It's not water or a cooling liquid anymore as it would be with a heat pump. It's now electricity. Now we use cables instead of pipes, and in doing so we make it many times easier and cheaper. But the principle is basically the same. We use power from the sun to get environmental energy into our building, and the heat pump does not make anything different. Yeah? It uses power from the ambient air, which is heated up by the sun, but it uses it with an evaporator, with a compressor, with a condenser, and with an expansion vessels, and with a cooling liquid. And this means maintenance, this means noise, and this means installation effort. Yeah? It's not the same situation when you do this with a pure electric heating system, which is powered mainly from PV. And if this building, and this is now the key point, if this building requires less energy from the public grid at the end of the year as the comparison with the heat pump, this is also the greener solution. This is the key point here. Very interesting concept, very new, and it's also for only for low energy buildings. And there's an example here, not far away from our location in Austria. It's in Linz, and this is a single family home. It has an area of 100 square meters. The owner of the building decided to take his money, which he has saved for building technology. And instead of investing it for a conventional heating system and put all the technology down into the basement, into a boiler room, he takes this money and spends it on a bigger PV system. So this PV system here has a power of 11 kilowatt peaks. And also the angle of the roof is very good for this principle. It is a 45-degree angle, and this is very important during wintertime, especially at our location in Austria. We have a lot of snow. Well, not this year, but usually we have a lot of snow. And when you plan such a building, you have to consider that. And all that remains from your building installation is the hot water boiler. Yeah, and then there's the PV inverter, and then there's the actor who makes this thing, PV ready. Yeah, it's just not an on-off heater anymore. This would not be PV ready. This would not be very smart. This is now the gearbox. You already know my comparison, which makes the heaters linear power controlled. Okay, a few other operation modes. I'm going through this very fast now. You can use up to 6 actors or up to 6 ACLE in one and the same network. And therefore you can also, and in doing so, you can also make electric space heating with mode 6, and you use more than one actor, for example. The multi-mode, as we call it, is available for all ways to use the actor, and it's also available for the green ACLE. Up to 6 units can be controlled by one signal source. Then there's mode 7. With mode 7, we have a PWM output signal. And with this output signal, we can control the RPMs of a pump. And in detail, it means we can control the RPM of a Velo pump from the, I think it's a German brand, Velo heat pumps. No, not heat pumps, pumps for heating. And what is the idea behind? Let's think about a huge storage tank, 5,000 liters or bigger. Then it would not be very wise to use immersion heaters inside, because you get all the energy in, but you do not reach target temperatures at the top. So you can use an external hydraulic system, and with the RPM control of the pump, we pump the hot heated liquid into the tank on the top, and in doing so, we can have a very hot heating zone on the top of the tank. So for big tanks, this is a very, very interesting operation mode. And my favorite one is the last one. It's mode 8. Mode 8 is the off-grid mode. So off-grid becomes more and more important for the people out there. Of course, there are the standard off-grid examples. Yeah, the mountain shelters that we have here in Austria in our Alps, which are purely off the grid. And in this cottages or shelters, usually there is a huge PV system which is combined to a battery system. And there are 3 brands that can already be used to control the actor in an off-grid system. And this happens by the shift of the frequency. In an off-grid systems, you can change the frequency. You do not need to have 50 hertz in every case. You can change the frequency. You are off the grid, no problem. And the idea is when the battery is fully charged, usually these PV systems, they shut down. Yeah? And from this moment forward, you waste all the energy. What we do is we detect via the frequency when the battery is full. And from this point forward, we start scaling up our power output on an immersion heater. So this is a very interesting solution for additional storage capacities when you're off the grid, but it also becomes more and more important for people who are working in the living in the urban area in the normal neighborhood. And from, I do not know, I'd be interested in your opinion, but what we see is more and more people are interested in living off the grid. They want to cut the wire to the power supply and say, I am living off grid. And this is a new trend, a very interesting trend. And I'm very, very curious what is the future of this trend. So very interesting. Just a story at the side of this. We are nearly at the end now. All the advantages. Actor, it's plug and play. It's small. It's an intuitive control with the display. We have an open communication interface. It's I already mentioned plug and play, and all those advantages again here on this slide. And now it's up to Eve to give you an economic point of view.
In dit geval spreken we over een referentieinstallatie in Labbeek met een piekvermogen van een kleine 7 kilowatt en een 5 kilowatt omvormer. Wat we hier zien is het aandeel van de opgewekte PV-energie die direct verbruikt wordt. En het rode deel is het deel die op het net geplaatst wordt om het dan later terug af te nemen. Dat is typisch in een opzet met prosumententarief. Als we daarop, en dan spreek ik enkel op sanitair warm water, als we daarop een MyPV oplossing loslaten, enkel met sanitair warm water, dan is het groene deel het deel die direct de PV-energie die direct wordt gebruikt en het rode deel het deel die op het net geplaatst wordt om er daarna weer af te halen. Stel dat je dit doet en dat je met een digitale meter zit en dat je overgaat naar het alternatieve tarief, waarbij dat je geen prosumententarief betaalt, zou je eigenlijk op vandaag al een voordeel doen van €175 per jaar. Kan ik aanbevelen om allemaal van de prosumententarief af te gaan? Van geval tot geval kan dat bekeken worden, maar zeker naar de toekomst toe, zeker naar volgend jaar toe, is dat wel een goede oplossing. Reinhard?
Okay, thank you. Our last slides, where do you get information from? There is the info center on our website, and there is everything you want to know. Beside our standard webpage, you find data sheets, you find manuals, you find wiring diagrams and schematics. You also find records of our webinars. So today, this was very general. There are also some more special webinars, and most of them are in German. Yeah, I know. But if you're interested in, you can log on our website. You just have to enter your email address, and that's it, nothing else. And then you have access to the records of our webinars as well. Where you do not have to log on is YouTube. Of course, there are most of the videos in German, but also a few in English. For example, a German one, which I can really recommend, is a video where I have shown the settings for hot water operation mode on the actual display. I have had the camera on above the display here, and I describe all the settings, all the steps, and I give you a lot of tips. And this gives you the chance to have a first impression of what you can expect when you're on the site, when you do the installation. And then it's not the case that you see the display the first time when you install the actor. You're already familiar with all the settings, with all the tips and tricks. So something that is really recommended from my side here. And then thank you very much for your attention. Eve, thank you very much from me to GPC Europe. It was really a pleasure and a very successful webinars. I take a look on the number of participants. So thank you very much to all of you who were with us this afternoon. And now there's the question if there are any questions left from our participants, Eve.
I have answered some questions during the presentation. If there are more questions, we can answer them now, or I think all participants have my email address, so they can send their questions directly to me.
Okay.
Okay. So thank you everybody for joining.
Thank you.
Bye bye.
Goodbye. Have a nice evening.
There's one question coming in.
Okay.
Okay, thanks. All right. Thank you.
Have a nice evening. All the best from Austria.
Thank you. Bye-bye.
Ciao.